Hello YouTube, and welcome to the first installment of this numerical analysis crash course. And this is just a video introduction to get your feet wet. If you are like me, who's a computer science major, you will encounter something to do with numerical analysis, or if you already have encountered it. For the purposes of this video, I'm just going to explain a few things about numerical analysis, what you find, and everything that you need for this video course and this course in general. So, without wasting any other time, let's get into it. So, we're going to talk about what numerical analysis is. We're also going to talk about some known concepts, and also we're also going to talk about calculus. We're gonna have a little calculus review, and my advice to you is that if you do not have any knowledge in calculus, which highly impossible, but if you don't, or if you have, let's just say, forgotten about calculus, well, I highly suggest that you have a little refresher course in calculus. But don't worry, I will be providing some little code snippets, sorry, on calculus, and I will also provide a cheat sheet for calculus. Majority of which is going to be needed only for numerical analysis. So you don't need to go through the entire process of calculus, knowing what this is, what that is, but it is very important that you do know these concepts. Alright, so without further ado, let's get into it. So, what is numerical analysis? Well, numerical analysis deals with solving equations that can't typically be solved using normal arithmetic means. What I mean by this is there are two types of mathematical equations: those that can be solved arithmetically and those that can't. Let me give you an example. So we have this guy here. Let's say you have limit as x approaches 2 for x squared minus 4 divided by x minus 2. How would you solve it? So there are two ways to solve this particular equation. The first step here is we get this function and solve it the normal arithmetic way, right? By saying that this is the difference of two squares on the top here. So we can factor this out and say x minus 2 multiplied by x plus 2 divided by x minus 2. Notice that we have x minus 2 on the top and we have x minus 2 on the bottom, so we can just cancel those guys out, and then we have our function limit as x approaches 2 for x plus 2, which is equal to 2 plus 2 and 4. And if you plug in 1.9, you see that you get the value 3.9, and so on and so forth for that value, and as you continue going there, right? We also have this type of relationship here where this guy, the first way, is not your typical way of solving, but it is a method. I'm showing arithmetic means of solving these equations. So, yeah, let's go to the second way and the second method, which we say limit as x approaches 2 for x squared minus 4 divided by x minus 2, which is equal to 4 minus 4 divided by 2 minus 2, which is 0 divided by 0. And you know this is undefined. And if we have an undefined value on our graph or in our function, we call that an asymptote, where this graph doesn't necessarily have a value at that point. You're going to learn more about asymptotes. I'm pretty sure you've gone through about what an asymptote is and all that. Basically, this is just a region within the graph that is undefined. So that is what an asymptote is. So for this function, we have an undefined value, which is 0. So at the point 0 of the graph, for this function is undefined at 0. So meaning it has a hole within that range is 0. So if we plug in 1.9, we notice that if you plug in 1.9 into this equation, we have 3.9. Same as this guy, and if we were to plug in 1.99, I'm pretty sure we'd get 3.99, and so on and so forth. So the only key difference between this function, or this way, and this way, is that this way of solving this equation will not give you an asymptote, where this one, it will give you a region within the graph that is undefined. So this is just a question, this is just an equation to help you understand, say, this question can be solved using arithmetic means. We have solved it using an arithmetic mean, right? So now let's look at questions that can't be solved using arithmetic means. So let's say we have the square root of 2. How would you solve it? Well, that's where numerical analysis comes in, because I don't think there's any arithmetic means of solving the square root of 2. None that I know of, anyway. So basically, numerical analysis deals with seemingly possible equations that one would have a hard time solving by using methods to approximate what that value is. Let me illustrate for you. So let's just say we want to find the square root of 2, right? So first things first, we are going to introduce x to the equation, and then we are going to make x subject to a formula. So this can be rewritten as if we were to get the square root of 2, plug it on the other side, which becomes negative, and then we can have this type of relationship, right? F of x is equals to x minus the square root of 2. And then we can also simplify the expression, and then we want to get rid of the radical here. So we can just introduce a square to this equation here. So we square this radical, and we square this function. And then we have this type of relationship where it's 2 equals to x squared. And then if we plug back 2 to the right hand side, we're going to have f of x, which is equal to x squared minus 2. And we have our equation or function. So we have used the method here by plugging in 2, we've plugged in 2, and we have found the function of the square root of 2. So the square root of 2 can also be represented on the graph using x squared minus 2, right? And then we find an interval within this graph here. And then after some fancy mathematics that we'll touch on later, we're going to have this type of solution. So this is a program that I wrote using Java, and basically solves for bisection, and that's what we're doing in this video. So our largest degree is 2, so meaning we have x to the power 2, and the variable is 1. And we have x to the power 1, which is 0, and then we get the value of the constant, which is negative 2. And let's just say our tolerance is negative 6. What is the interval? Let's just say 1, 2. And then we have this type of relationship where we can see that the value of the square root of 2 is seemingly close to 1.41406, right? And the more you keep on iterating for this function, you see that the value just keeps getting closer and closer and closer to the value of the square root of 2 rather than the actual value itself. Because if you plug in square root of 2 on your calculator, you will get something within this range. So we've seen now that we can use numerical analysis to actually solve for these type of functions. We have methods here that we incorporated, and then we've gotten our value. So that's basically numerical analysis for you, and it helps you identify or find values that are closer to the actual value than it is by approximating what that value actually is. We don't know the exact value, but we do know that it's within that range. Alright, so I talked about this having a graph, which is x squared minus 2, and it's something in the format. So we have this type of equation, and our interval points were 1, 2, so meaning we did have something between these range. So basically, that's what numerical analysis deals with, and the more we go on, the more you understand how to actually solve these equations. All right. So with that being said, this is the course outline for our videos in the future. So first things first, we're going to talk about calculus review and their theorems, and we're also going to talk about solutions to functions in one variable, which include the bisection method that we're from using to solve the square root of 2. That's called bisection or binary search method. We're also going to talk about Newton-Raphson method, secant method, and I will talk about fixed point iteration later on, but for now that's just a bridge we'll have to cross when we get there. And we're going to talk about polynomial approximation and interpolation. This involves Taylor's polynomials and Lagrange polynomial interpolation and something in those lines. And then we're going to talk about numerical differentiation. We're going to talk about Newton's divided differences. Yeah, something like that. So I hope this just gave you a brief introduction to numerical analysis and what is there in store for you. And with that being said, I think I will see you in the next video. Take care and stay blessed.